Alright, the next video I was asked to look at was Boxplots, and so this would correspond to Module 6, is sort of the first time we introduced Boxplots. And then it was also used a lot in Module 9 when we did analysis of variance, of sort of comparing the different groups and to understand why the F statistic was what it was. So a quick first refresher on what a boxplot is. We have 5 different numbers that we need to know what a boxplot is. We need the minimum value, we need the first quartile, we need the median, we need the third quartile, and then we need the maximum. So those are my 5 different numbers that I need that comprise my box plot. And so the first thing I know is that really what these 5 numbers do is take my data and break them up into quarters. So 25% of my observations will be between the minimum in Q1, because Q1 is my first quartile, so that first quarter of the data. Between Q1 and the median is also 25% of my observations. Between the median and Q3 is another 25%. And then finally between Q3 and the max is also 25%. So 25% of your data points are going to fall between each of those spots. Another thing we know is actually different ways that we can get 50%. Because my data, that median, cuts my data in half. So 50% of my observations fall between the minimum and the median. And the other half fall then between the median and the maximum. So there was another way we talked about 50%, and that was between that Q1 and that Q3 when we talked about the interquartile range. So there's also 50% between those 2 values, sometimes an interesting one because that's the middle 50% of your observations. So how that then looks when we look at this box plot down here. So here I was looking at how long delays are at the Chicago O'Hare Airport. And so this green line, which is not part of a box plot, is actually where the mean falls. So this smallest value here is our minimum. Largest value here is our maximum. The line in the middle of the box is our median. And then the 2 ends of the box are our Q1 and our Q3. So I'll just label those real quick. So this is our min. This is Q1. That's our median. This is our Q3, and then out here is our max. So then if I were to try to about ballpark where some of these values fall, I'll try to extend my lines down, so I can at least try to estimate where some of these values are. So the third quartile here is a little bit smaller than 100. I'm just going to say that's 90. This median here looks to be pretty close to halfway between 0 and 100. So I'm going to say that that's 50. My Q1 here, I'm going to say is about 25. And then the min here I'll say is about 15. My max is quite big. It's bigger than 400 here. I'll estimate that to be about 430. And sometimes I give you those numbers from StatCrunch, but just so we have actual numbers, as we're interpreting here, I'm trying to ballpark where those values are. And these values were in minutes. So things I could say. So then I could say that 50% of the delays there are a few different ways I could say that. So 50% of the delays were less than 50 minutes. Because that 50 minutes is what I estimated my median here to be. So half of the delays are less than that. I could also say that 50% were more than that value. And that would also be true because the median has half of the data on either side of it. And then I could also say that 50% is between my Q1 and my Q3. So here, based upon my numbers, I would say we're between 25 and 90 minutes. So those are some different things I can say about 50% with my box plot. I could also say, of course, that my smallest delay length, or shortest delay, was 15 minutes. My longest delay was 430 minutes, which is over 7 hours. That's a long delay. Now finally, I haven't addressed this green line that we put on here, and this we really started seeing show up when we were doing ANOVA. So what this number N again is the mean. What's nice about having that number, not just for ANOVA, but here then I can see how the mean and the median compare. Because if my shape is symmetric, the mean and median should be about the same. So I can see here my mean is higher than my median. So the fact that the mean is quite a bit higher, so I'll say quite a bit higher than my median here, helps me actually know then that my data set is skewed to the right. I can also see that with the fact that this is such a very long value, right? Because again, keep in mind what these values are telling me. So 25% of my delays were between 15 and 25 minutes. So that was a quarter of the values. Another 25% was between 25 and 50 minutes. Another 25% were between 50 and 90 minutes. But now think about how much I've covered so far. Like, right, so 75% is between 15 and 90 minutes. That's a range there of only 75 minutes that 75% of my data fell between. And then 25% lastly fell between 90 and 430 minutes. That's much more spread out. That's not going to have very high bars if I think about a histogram, versus these would have much higher bars for the histogram because there's a lot of data in this little area. Now let's talk about how this pertained to what we were doing with ANOVA and comparing the box plots. So when we're talking about that F statistic, we're kind of trying to compare where the means are compared to how much variability is going on in these boxes themselves. So the first thing that I did here is, if you actually notice, I have 4 graphs, A, B, C, and D, in all of them. In both graphs, A has a mean of 2, B has a mean of 3, C has a mean of 4, and D has a mean of 5. And then what I want to look at is the fact that if you notice here, my scales are different. So this one goes from 0 to 12. This one goes from 0 to 7. So that's one thing to be careful of, is making sure you notice the scales. So look at how long my box plots are here. This one goes from 1 to 12, which is 11. This one goes from 1 to 10, which is 9. This one goes from 0 to 9, which is 9, and 0 to 7, which is 7. So each of my box plots here are at least 7 wide. Versus over here, this one goes from 0 to 4, so that's only 4 wide, 1 to 5, 4 wide, 2 to 6, 4 wide, and 3 to 7, 4 wide. So this one only has a variability of 4 going on totally in the box plot, versus I have a much larger spread going on over here with these box plots. So what that meant for us is, if the means are the same, the one that has larger spread in the box plot, we'll have a smaller f. Because that spread of the box plots went on the bottom in the denominator. So that's how box plots were helpful in us determining what our F statistic would be. So that covers what I was doing with box plots for this video.